Hi guys, welcome to my channel, and this is the second video in water technology. The topic is expression and units of hardness. You can watch my first video in water technology that explain the introduction of water sources, hardness, types and disadvantages of hardness. The link is provided in the description. And we already discussed hardness. Hardness is the characteristic of water which does not give good lather when it is interacted with the soap. Instead of good lather, it produces white scum, insoluble precipitate. So it is mainly because of six salts of calcium and magnesium. Those salts are calcium chloride, calcium sulfide, calcium bicarbonate, magnesium chloride, magnesium sulfide, magnesium bicarbonate. These six salts are completely dissolved in the water. That's why it's creating problem. If they are not soluble in water, we can easily removable by filtration process, but they are completely soluble in water. That's make us very difficult to remove them from water, these creating hardness of water. Here the important thing is, if water contains any one of these salt, no, not required all six salts, any one of these salt present in the water, that water is also called hard water. So for example, calcium chloride is only present in the water, that is also called hard water. If six salts is also present in the water, that water also called hard water. So this is important thing. So I have I am giving a problem to you. There is a four beakers is there, A B C D beakers is there. Each is filled with the equal amount of pure water. That means each beaker is filled with the 1 liter of pure water. Pure water means only H2O. There is no other contaminants like like hardness causing salts, dissolved salts, gases. Nothing is there. Only water is there. In that water I added in first beaker 1 milligram of 1 gram of magnesium chloride, in second beaker 2 gram of magnesium chloride, and third beaker C beaker 5 gram of magnesium chloride, and fourth beaker the name is D, and added 10 grams of magnesium chloride. Now question is, which beaker having much hard water? So you can easily tell, you can easily answer the question. Why? Because the same thing in different quantities. Magnesium chloride itself in the four beakers, but the quantity is different. One beaker having 1 gram, second beaker having 2 grams, and fourth beaker having 10 grams. So by knowing, by looking at the number, you can easily tell which beaker having much hardness, which beaker having much hard water. The answer is D. Why? Because it having 10 grams of magnesium chloride. It's very easy, it's very simple. So go for next case. Again four beakers is there, again filled with the same type of water and same amount of water, but A beaker is filled with 10 grams of calcium chloride, B beaker filling with the 10 grams of magnesium chloride, and C beaker is filling with the adding with the 10 grams of calcium sulfide, and D beaker added by 10 grams of magnesium sulfide. So these are four salts are responsible for the hardness, right? If water only having calcium chloride, that water is can call that water can call hard water. If the water having magnesium sulfide itself only, that water also called hard water. So which beaker having much hard water? Now the quantity is same, every beaker having 10 grams, but substance is different. One beaker having calcium chloride, another having calcium sulfide, another one has magnesium sulfide, and other having magnesium chloride. Now it is difficult to conclude which beaker having much hard water. Okay, so before going to solve this problem, so expression of money, so different countries having different value for money. For like India, money name is rupee, and America having dollars, China having yuans, and South Africa having rands. So these all are same value? No, $1 is not equal to 1 rupee, 1 rupee is not equal to 1 rand, 1 rand is not equal to 1 yuan. So they all are money, but they have their own value. So to take a reference. So in worldwide economy or share market, everything will take a reference to express value of money by taking one reference, that is called dollar. So if you observe the stock market or world economy, they always tell the value of money in dollars. That means they are converting rupees into dollars, they are converting yuans into dollars, they are converting rands into dollars. Though there is so much type of money types is there, everything will converting into dollar, they are taking dollar as reference. The same principle if you apply here, we have a different types of hardness causing salts. Okay, if you converting into one reference compound, then you can easily conclude the last question. What I am asking, the last question, by converting 10 grams of salt, 10 grams of magnesium salt equal to some x grams of one salt. Okay, so like that, if you convert all these salts into reference compound, then by seeing the quantity of the reference compound, you can easily tell which water is having much hardness. So that is called CaCO3 equivalent hardness. Hardness of water is expressed in terms of number of parts of CaCO3 equivalents. That means before going to calculation of CaCO3 equivalents, now 10 grams of CaCl2 is equal to how much of CaCO3 hardness? Okay, 10 grams of magnesium chloride equal to how much of CaCO3 equivalent? 10 grams of calcium sulfide is equal to how much of calcium carbonate hardness? Then the value only change, X CaCO3, Y CaCO3, Z CaCO3, like that options will come. By knowing the X, Y, Z value, you can know that those are only numbers. X, Y, Z is a numbers. By seeing number, you can easily tell which water having odd water. The formula for that is CaCO3 equivalent hardness is weight of hardness causing salt, weight of hardness producing salt by molecular weight of hardness producing salt. That means weight of hardness causing salt by molecular weight of hardness causing salts into molecular weight of CaCO3. The molecular weight of CaCO3 is equal to 100. Just what you have to do, you know the weight of, for example, if you observe the beaker A containing the 10 gram of calcium chloride. So here calcium chloride is the responsible for hardness. That's why 10 grams is the weight of hardness producing salt. 10 by, so 10 by and molecular weight of hardness causing salts. Here hardness causing salts CaCl2. So you can see molecular weight of hardness causing salts 111. So 10 by 111. So into molecular weight of CaCO3. Molecular weight of CaCO3 is equal to 100. So you can get a value, you can get a numerical value here. So some value will get, some x value will get, you can calculate here, x value will get. Like that, if you do the remaining beakers, if you apply the same principle for remaining beaker, 10 by magnesium 10 grams, weight is 10 grams, and magnesium chloride molecular is 95, 10 by 95 into 100, and here 10 by calcium sulfide 136, 10 by 136 into 100, and magnesium sulfide 10 by 120 into 100, you will get a values, x value, y value, z value. Okay, but these all are in the CaCO3 equivalents. Now you can easily tell which having higher value, that having higher hardness. So like that, you need to convert hardness of different salts into single salt, that is called CaCO3 equivalent hardness. Why we have to convert all hardness into CaCO3 hardness? Why we have to take a reference CaCO3? So for measurement purpose, for calculation purpose, its molecular weight is 100. It is very easy to calculate. And next thing is, in the experimental session, CaCO3 is most insoluble salt in the water. So you can easily remove total amount of CaCO3 can be easily removed from the water. These two are the reason for taking CaCO3 as a reference compound. So like that, you can easily tell hardness because of different salts, by converting into single reference compound, that is called CaCO3 equivalent hardness. So hardness is not expressed in terms of different salts. It's only expressed in terms of single salt, that is called CaCO3, and the hardness is called CaCO3 equivalent hardness. The formula is weight of hardness producing salt by molecular weight of hardness producing salt into molecular weight of CaCO3. So for calculations, if I ask the problem in the examination, at least you have to remember these molecular weights. Why? Because we are only there is a chance only because of these six salts. These six salts only produces the hardness causing salts, and along with the CaCO3 molecule weight. Okay. So next, units of hardness. That is the expression. Expression and units are both are different. Units mean, so just like we have a different quantities having different qualitative parameters having different units, like speed having unit, distance having unit, like that hardness also having units. So those are parts per million. First one is parts per million, generally expressed in the ppm. Ppm mean parts per million. So it can be expressed like this: the number of parts of calcium carbonate equivalent hardness for 1 million parts of water. That means how much hardness causing salts present in 10 lakhs parts of the water. So 1 ppm mean 1 part of CaCO3 equivalent hardness present in 10 lakhs of water, 10 lakhs parts of water. That means hardness is generally very low quantity. That's why you cannot measure in grams or something. It is a very low quantity. That's why we have to go low scale, like ppm scale. Okay. And next one is milligram per liter. That means how many milligrams of hardness causing salts present in 1 liter solution. If you take 1 liter solution, in that 1 liter solution, how much solute particles of calcium carbonate equivalent hardness present in the water. So that is called milligram per liter. So generally 1 milligram per liter is equal to 1 ppm. That means milligram per liter and parts per millions both are equal, quantitatively equal values. Next one is Clark degrees unit. Clark degree mean, so it is a 1 part of CaCO3 equivalent hardness present in 70,000 parts of water molecules. Okay, 70,000 parts of water. Okay, that is 1 ppm is equal to 0.07 Clark degree. If you convert the units, you will get a 1 ppm is equal to 0.07 degree Clarks. So here ppm means 1 part present in 10 lakhs parts. Clark degree mean 1 part present in 70,000 parts. Remember it. Okay. So next, French degree mean 1 part present in 1 lakh parts. 1 part present in 1 lakh part. That means 1 part of CaCO3 hardness causing salts present in 1 lakh parts of water is called French degree. So 1 ppm is equal to 0.1 degree French. Okay. So these are the units, but generally most of the used units are parts per million or milligram per liter. Parts per million means 1 part present in 10 lakhs parts. Okay. So this is the expression and units of the hardness. So these are the very important. If you observe any textbooks or any sources, hardness is expressed in ppms. That is also in terms of CaCO3 equivalent hardness. Okay. So this is the topic for today. Thank you for listening.